Hello guys, welcome to my class. In this class, I will teach a topic of an integration, and this is class number 1, and we will cover a subtopic of introduction to integration. My name is Engineer Goodluck, and contact me through my email goodluck.daudi@gmail.com, and I'm from Tanzania. You can find me in Dar es Salaam region or Mbeya, depending on working situation. Okay, what is an integration? Some define an integration as an antiderivative or is reverse of differentiation, and some define as a summation of a small portion of the function to get the whole function. All these definitions are applicable, but the first definition is most applicable in mathematics, and the second is applicable in mathematics and other area of science, like during derivation of physics formulas. Okay. Note, the idea of integration is very useful in mathematics and other fields of science, like in deriving physics formula. Integration is denoted by card S. Consider this basic understanding. One, when you integrate derivative of f of x, we get the original function f of x. This is true only if f of x is in front of d. When it is behind of derivative, we talk on other things, and during calculation we plus constant. I will show you later. And the 2, f of derivative of x, we get x. It means integral is a reverse of the differentiation. So this integral and the derivative cancel each other and leave only x. And the same is true if x is behind of derivative of x, we talk of other things. But if x is in front of the derivative of x, the integral sign cancel with the derivative sign to give out x. And 3, what if x raised to n is behind of derivative of x? What do we get? And this is very interesting. Note, in order to understand an integration, we must call back the idea of differentiation. Consider this function f of x is equal to x raised to n. find its first derivative. To find the first derivative of this function, first we put n at this position, and second we minus 1 from n. First we put n at this position, and then second we minus 1 at this n. Question arises how I can get back the original function f of x from the derivative 1. The answer is by integration, and it is denoted as the following: that to get f of x is equal to integral of f dash of x dx. So you must be very careful. In this position is where we see f dash of x. So we replace f dash of x with its value, that is n x n minus 1. And n is a variable that does not vary the derivative of x, and x is a variable that varies the derivative of x. So we consider n as a constant and we take out of integration. It means any constant has no effect on integration, so we deal with x. Okay. We have already shown that this n is a constant, but to go out of integral sign, we must plus 1 at this power and divide by this 1. All of these steps are levers to differentiation. In differentiation, first we put n at this position and then we minus. But in integration, first we plus 1 at this power and then we divide by the result of plusing 1 at this power. So what we get? We must plus constant because when we differentiate, we remove the constant. Okay, let me go back a little more. I will show you something. That after getting this answer, I plus a constant. I plus a constant because during differentiation, the derivative of a constant is 0. So, as integration is a reverse of differentiation, we place c as a constant back because we don't know whether during differentiation we differentiate a constant or not. So if we don't differentiate the constant, it means the value of c will be 0. But you must place it. Generally, integral of x varies to n is equal to integral of x raised to n dx is equal to, first we plus by 1 and the second we divide the result of plusing 1 and we plus with a constant. Generally, if we have the function which is equal to x raised to n dx, we get the following results. First, since we integrate from this one to this one, we plus 1 to the power of n, and we divide by this result, and we plus constant. We do so because when we differentiate a constant, we get 0. So, to get back the constant, we must place any variable. Here, I assume a constant is equal to letter C. This formula is valid for the following functions. First, if f dash of x, this place is where we place f dash of x, so the value of f dash of x must be equal to linear function, or the value of f dash of x must be equal to quadratic, or the value of f dash of x is equal to cubic function, or this function f dash of x can be of the form summation of x raised to n, where n is equal to 0 up to n. So when I express this in expansion form, I get things like this one. Okay, I think I complete my introduction, and in the next lesson I will teach on integration of a simple expressions. And mind you, in order to understand an integration, you must understand well the idea of integration rather than solving a lot of questions. See you later.